When considering chemical reactions in aqueous solutions in a quantitative manner, the concentration of the reactants is generally more important than the actual amount of reactants present in the solution. In this video, we introduce ourselves to the concept of concentration, and in particular one way of quantifying concentration, and that is molarity. In general terms, concentration refers to the amount of dissolved solute in a specified amount of solvent, or in a specified amount of solution. In the former case, we can express that mathematically as concentration equals the amount of solute divided by the amount of solvent. In the latter case, we can express it as the amount of solute divided by the amount of solution. In terms of the amount of solute, we can quantify that in a number of ways, including moles, remembering that moles is the SI unit for the amount of matter. But you will see concentration terms and concentration units where mass is also used for the amount of solute, or sometimes even volume is used, especially in cases where the dissolved solute is a liquid at room temperature and pressure. In terms of quantifying the amount of solvent or solution, typically the volume of the solvent or solution is used, as most solvents we encounter are liquids at room temperature and pressure. And the unit of volume that is typically employed is litres, but again, you will see the amount of solvent or the amount of solution can also be expressed in terms of mass quantities such as kilograms. The concentration expression that we will be most interested in is the amount of solute divided by the amount of solution, and in particular we want to quantify the amount of solute in terms of moles, and we want to quantify the amount of solution in terms of litres. When we define concentration in this way, it is known as molarity, and molarity, which has a capital M as its symbol, equals moles of solute divided by the litres of solution, or you will likely see it more often in this simplified form of molarity equals moles divided by litres. But remember, we are talking about litres of solution, not litres of solvent, and there is a subtle but important difference. The units for molarity are moles per litre, which can be expressed in a couple of mathematical forms seen here, but you will also see the capital M unit being used alongside the term molar. So, for example, a solution that has a concentration of 0.5 moles per litre is often expressed as being a concentration of 0.5 molar, with the capital M as the unit. So molarity equals moles on litres, and this is an important new relationship that we have to use, almost as important as the molar mass relationship that we have already encountered. And like the molar mass relationship, we are going to need to rearrange this equation. So for example, to make moles the subject of the equation, the moles of a solute in solution equals the molarity of the solute times the volume of the solution in litres. Similarly, we can make litres the subject of the equation, where the volume of solution in litres equals the moles of solute in the solution divided by its concentration, expressed as molarity. So let's look at a typical example of how we would use the molarity equation. Calculate the molarity of a solution by dissolving 26.9 grams of sodium sulfate, Na2SO4, in enough water to form 225 milliliters of solution. Now, make no mistake about it, when we are calculating molarity, we need both the moles and the litres, and unfortunately, this question gives us neither. It does, however, give us the mass, and we know that we can relate the mass to the moles through the molar mass equation. So 26.9 grams of sodium sulfate can actually be converted to moles of sodium sulfate by dividing the mass by the molar mass of sodium sulfate. We also know that the 225 milliliters can be converted to litres of solution by using our unit conversion approaches. And so we're going to have to do both these steps in order to calculate the molarity of this solution. So step 1, calculating the moles of sodium sulfate. Moles of sodium sulfate equals mass of sodium sulfate divided by the molar mass of sodium sulfate. So we've got our 26.9 grams of sodium sulfate, and we need to divide it by its molar mass. Very quickly, the molar mass is calculated as 2 times the molar mass for sodium, plus 1 times the molar mass for sulfur, plus 4 times the molar mass for oxygen. And that comes to 142.0 grams per mole. We can substitute that into the molar mass equation, and we plug those numbers into our calculator, and we get 0.189 moles of sodium sulfate, which we can then substitute that into our molarity equation. Step 2 involves the unit conversion of 225 millilitres into litres. And what we do here is find the relevant conversion factor, 1 litre divided by 1,000 millilitres. Now 1,000 millilitres and 1 litre are identical quantities, just expressed in different units. So in effect, we are multiplying the 225 millilitres by unity, by the number 1. But the point here is that by having this conversion factor, we can readily cancel out the milliliter unit and we'll just be left with litres as the unit. So 225 millilitres is equivalent to 0.225 litres, which we are now able to substitute into our molarity expression to allow completion of step 3, calculating the molarity. And plugging those numbers into our calculator gives us 0.842 moles per litre as the molarity for this solution, which we can also express as 0.842 molar with capital M as the units. And as I said earlier, we will see and hear both of these terminologies used.